Hello everyone. In this video we are going to study about the chemical equilibrium. After going through the video, students will be able to understand meaning of term equilibrium, types of equilibrium, its characteristics, law of mass action, relationship between different types of equilibrium constants, significance of equilibrium constant, how to write Kc and Kp, to calculate the values of Kc from given equilibrium concentrations, significance of Qc, that is the reaction quotient. Now what is equilibrium? The meaning of equilibrium in the English dictionary means a balance between two opposite forces. Similarly, when we apply this term to chemical process, there is a balance between the forward reaction and the backward reaction. For example, if we dissolve a given amount of sugar in a given amount of solvent, then after adding certain amount of sugar, dissolution stops. It is because the two processes are in equilibrium, that is, dissolution and crystallization are in equilibrium with one another. Equilibrium is shown by double half-headed arrow. So equilibrium is equilibrium. At equilibrium it seems that the reaction has stopped, but the rate of forward reaction becomes equal to rate of backward reaction. Equilibrium is a state in which concentration of reactants and products do not change with the passage of time. There are two types of equilibrium: physical equilibrium and chemical equilibrium. Physical equilibrium occurs in physical processes, that is, there is a change in physical state of the substance. Whereas in chemical equilibrium, a new chemical is formed from reactants. Equilibrium is shown by half-headed arrow. Graphically, equilibrium, if we draw a graph between reaction rate and the time, the rate of reaction for forward reaction decreases, whereas rate of reaction for backward reaction increases. And at equilibrium, the rate of both the reactions become equal, and this is the equilibrium state. Similarly, if we draw a graph between concentration and time, the rate of formation of products increases, that is, concentration of products increases, whereas concentration of reactants decreases. Characteristics of chemical equilibrium. Chemical equilibrium is dynamic in nature. The properties like concentration, pressure, volume, temperature becomes constant at equilibrium. Equilibrium can be obtained from any direction. It can be attained only in closed system. Catalyst does not change the equilibrium state. Now let us try to understand the meaning of all the terms one by one. What do you mean by dynamic in nature? Dynamic nature of equilibrium means the reaction actually at micro level, that is at molecular level, does not stop. The rate of two opposite reactions becomes equal, that is, in a given mixture the reactants products are present. The rate at which the reactants are converting into products becomes equal to the rate with which products molecules change into reactant molecules. This is the meaning of dynamic in nature. Law of mass action. Now, how can we tell the reaction has occurred? According to this law, the rate of forward reaction or backward reaction is directly proportional to concentration of its reactants. For example, in this case, for forward reaction, A and B are the reactants. So, rate of reaction is directly proportional to concentration of A and B. Here A and B, each concentration term is raised to power equal to the coefficient present in the balanced equation. Similarly, rate of backward reaction. Now the backward reaction, for backward reactions, C and D are the reactants. So rate of backward reaction is like this, but at equilibrium Rf equal to Rb. So if we equalize both the terms, then we get a constant known as equilibrium constant. So equilibrium constant is, you can see, it is the ratio of products of concentration of products to product of concentration of reactants, and each concentration term is raised to power equal to the coefficients present in the balanced equation. What happens if the reactants and products are present in the gaseous state? In the gaseous state, equilibrium constant in terms of pressure is used. So since we know PV equal to nRT and P is equal to nRT upon V. N upon V is called concentration. So instead of P, we can write CRT. CRT and its power equal to coefficient. So this is the relationship. Kp is equal to Kc RT raised to power delta Ng, that is change in number of moles of products minus number of moles of reactants. Now reaction quotient. Reaction quotient is also just like equilibrium constant, except the concentrations in reaction quotient are not equilibrium concentrations. It is also equal to the ratio of concentration of products to concentration of reactants. And the concentration of products and reactants are not equilibrium concentrations. Now two cases arises. What are those? If reaction quotient is greater than equilibrium constant, it means the concentration of products are more. It means the reaction should go in the forward direction to make the equilibrium concentrations of C and D. Similarly, when QC is less than Kc, it means concentrations of C and D are less. To make the concentration of C and D equal to equilibrium concentrations, the reactants must change into the products. That is, the reaction must go in the forward direction. These are the some questions which you can solve very easily. Thank you.